Hi, today we're going to talk about how to solder the Quby printed circuit board. And here's a board that hasn't had the through-hole components soldered in place already, but it does have the surface mount devices, you know, the resistors and capacitors soldered, as well as the SD card. So that's what the board looks like. And then here are some examples of through-hole components. These are PH2 connectors, and they just plug in like this. And when you plug these in, it's very important that these open areas face inwards, because those are for keyed connectors that plug into them. And if you turn them around the other way, then they're going to connect things up improperly and could damage things. So make sure these open areas on all these connectors face inwards, and I'll mention that again later. Here's a USB jack. It's a 4-pin device, and just line up the 4 pins first and then press it in place. And then you just flip the board over, and you can solder the components in place. This is the solder side. This is where you're going to do all your soldering, with one possible exception. So that's what the board looks like before it's been soldered up. And over here I have a board that's already been soldered, so all the devices are in place. And when I solder the board, what I do is I put the north side facing away from me, or at the top. And if you do that, your SD card socket here will be on the upper left corner here, or the northwest corner. And you got the power jack will go over here on the lower left. And so my strategy for soldering this board is to solder in place most of the low profile components first. That way when you flip the board over, it'll lay more flat, and you can solder it more easily. So what I do is solder the crystal in first, and this is a 2-pin device. It doesn't have polarity, but I try to solder it such that the marking on the package is right side up relative to the silkscreen legend here. And when you solder this component, try not to use too much heat with your iron, because it's kind of a sensitive component. And it's a very important component because it provides the heartbeat, so to speak, for the propeller chip. So don't overheat that, or you might stress it. So after you solder the crystal, then you can move on to these 3 sockets here. And these are 2.54 millimeter or 0.1 inch pin spacing on these, and they're pretty easy to solder. And I solder in the 40-pin dip socket for the propeller chip first. And when you solder this in place, you want to make sure that this little notch here on the one end of the socket is facing the north side of the board. And the silkscreen legend there tells you how to orientate that. If you soldered that in backwards, you know, the socket would still work, but it would be lying to whoever was inserting the chip in there, telling them to put the chip in backwards, and that could damage the chip. So take your time when you solder in the sockets to make sure you get the notches facing the right direction. And for these 2 8-pin sockets here, the notches on those should face to the right or to the east side. So this one up here at the top, that's for the EEPROM chip, and that's used to boot the system. And then the lower one down here is for the audio amplifier chip. Okay, once you solder your sockets in place, then you can move outwards a little bit to these white PH2 connectors. And again, when you put these in, you want to make sure that the open areas face in. So that's very important. That way you don't connect the cables wrongly to the board and damage something. And when I solder these, I start with these 4 12-pin connectors, and solder those in place first. They carry the video signals to the driver boards. You know, the red, green, and blue VGA signals, as well as the horizontal and vertical sync. And then after you solder those, you can solder these 4 4-pin connectors, and they carry power and ground. And when you solder them, you can short the outer 2 pairs of pins together if you want, but don't short the middle pair, because that would short power and ground. Okay, once those are soldered in place, then you can move out and solder in these 4 USB Type A sockets, and they're pretty easy to solder. They're just 4-pin devices, and you can put those in place and they'll probably hold without taping. By the way, you'll probably need to tape in these 4-pin sockets when you solder those in place, but the USB ones probably don't need tape, but you can tape them in just in case. You want to make sure that they're flush against the board when you solder them in place. And on these, the 4 pins, the 2 middle pins are pretty close together. So you want to be careful when you're soldering those that you don't short those 2 pins together. Now if you did short them and you plugged in a keyboard, the keyboard wouldn't work. So then you'd have to get out your iron and clear the short, and then everything should be okay. But try not to short them from the beginning. After you solder these in place, you can move over here to this a socket here, this white one, for the propeller or prop plug. That's used to program the board, and that's pretty easy to solder. And then right behind it, you're going to be soldering in this 3-pin IR detector. And you should solder it such that the little lens on it is facing north or facing out. Then you can come over here and solder these 2 resistor packs in place. There's a 6-pin one and a 7-pin one. And these have 10K pull-up resistors for the keyboards and also this the SD card. And there's a little marking on each of these packages, a little diamond, I think. And you want the diamond to be right across from these little white dots on the printed circuit board. Otherwise, they won't be connected properly. So basically they have polarity, so be careful when you solder those in place. Then you can solder in this 6-pin female header over here, and it doesn't have polarity, but it's for the real-time clock module, and I've had one right here. And when you plug in the module, you do want to plug it in the right way. So when you plug it in, the chips on it, on the module, should face outwards, and the battery will face inwards. So you plug it in like this. like this. So make sure you plug that in the right way. Next, you can come down here to the audio section and solder in this 2-pin header for this speaker cable. It's a male header, and the speaker just plugs in like that. Then you can solder in this 220 microfarad electrolytic capacitor here, and this is a metal can. Now this component does have polarity, so you want to get it right. The plus is at the top, minus is at the bottom. And if you get that wrong, this device will start smoking and can even explode. So make sure you solder this in place with the correct polarity. Next, you can solder, secure the speaker, and how we do that is solder in 3 right-angle pins right here. And when you solder these in, push the metal pins down a little bit within the little plastic part to lower them a little bit. Then you can slide the speaker underneath there, and then solder in 1 or 2 more pins over here on the right side. And that's going to lock that speaker in place, because you wouldn't want it moving around in the console when it was powered up, because it could short something out. So that's how we solder that in place. And underneath the speaker, there's a little grill with holes to let the sound come out. Then we can come over here and solder in this power jack, and it's pretty easy to solder, but it does have 2 little posts or feet on this side here, and they need to recess into the 2 little holes in the printed circuit board. So you want to press that down, get that seated well, and you might want to tape that in place before you flip it over. And then when you flip it over, you might press on the board to make sure it's making good contact with the board before you solder it in place. Then you can solder in the power switch, and for the power switch, you want to make sure the little flange on the switch, or the little bezel, I guess, you want to make sure it's flush against the edge of the printed circuit board. I'm talking about the lower part of the flange here. And then the body of the switch should be flush against the board as well. Now, there's 2 kinds of switches that the board uses. One has right angle pins, and it's really easy to solder in place. There's 2 holes here, so that's quite convenient. And the other kind is a straight pin, and if you have that kind, first you're going to need to solder in these 3, you can see a 6-pin header here, and then you'll put your switch in position carefully and tape it down, and then you'll solder on the top side here each of these 3 pins to a pair of header pins. So that's how that gets soldered in place. And then you'll come along and clip off the tops of the header pins to lower the profile of it. So that's a little bit more challenging, but quite doable. So that's how the switch solders in place. And then at that point, it's a good time to test the board to make sure that you don't have any shorts between power and ground. So I've got a meter here. I'll just show you how we do that. Put your meter on the continuity check, and then make sure that it's working. So you want to short your probes together, and you should hear a beep. And sometimes you won't hear a beep because the meter probes might be a little bit bad. Let's see here. Not sure why this one's not beeping. Hello. There we go. Okay. Confirm that your meter is working properly first, and then you can put the black probe on the ground pad here, and then the red one should go over here to the middle pad or of the where the voltage regulator is going to go. And you shouldn't hear a beep because that would indicate a short. Now if you come to this pin on the left, that's connected obviously because that's the ground pin. But the middle pin, or in this case it's connected to the tab, you shouldn't hear a beep. So if you don't hear a beep, then that means that you probably don't have any power to ground shorts. So then you can proceed to the next step, which is to solder in this power supply here. And to begin with, you solder in these 4 tantalum capacitors, and they do have polarity. It's very important that you get the polarity on these right, just like for the electrolytic over here. And there's a little plus sign on one side of each of these capacitors, and you want that plus sign to be closest to where the voltage regulators go, or facing to the north side of the board. So make sure that all 4 of these have the plus sign facing the right way. And after you get those soldered in place, you can go ahead and solder in the 5-volt regulator. Make sure that you don't solder in the 3-volt. Solder in the 5-volt on the left side here. And once that's in place, then you want to go ahead and get your meter and check that the voltage is correct. So go ahead and put your meter on voltage, and get your power adapter out, and go ahead and plug in the power adapter, and turn on the power switch to power up the board. Then you can measure the voltage. So put your black probe over here on the ground pad just like before, and then the red probe can go on this tab of the voltage regulator because it's connected to the output pin, which is the center pin. And you should read about 5 volts, and we're reading 5.01. So that's quite close. That's what we want. Anything near 5 volts should be good. You know, say 4.9 to 5.1, something in that range. So this one's good. And after you've checked the voltage on that one, you can go ahead and solder in the 3.3 volt regulator. And once you got it in place, you'll want to check the voltage on it as well. Make sure that it's reading pretty close to 3.3 volts. And by the way, these tabs, since they're connected to the output pins, you want to make sure that the 2 tabs here on these voltage regulators don't touch each other. Otherwise, you'd have a short between the 2 different voltages. And so there should be a gap between the 2 voltage regulators. So if you got your 3.3 volts here on this one here on the right, then the board pretty much checks out, and you can go ahead and populate these sockets with the IC chips. So just make sure that you insert the chips right. Propeller chip, the little notch on it should face north or be at the top here, and like the little notch on the socket if you've soldered it in properly, and like the little legend on the printed circuit board. And then the 2 other chips, the EEPROM here at the top, the notch should go to the right, and on the audio chip, the notch should also go to the right. And then you can power up the board, and then you could, for example, go ahead and plug in a prop plug to test to see if it was working. So that's how you solder the through-hole components for the Quby printed circuit board. I hope that gives you a roadmap before you begin. That way you know where you're going. It'll make it a little bit easier for you. And I think this is a very enjoyable board to solder. you know, it's kind of satisfying to know when you're soldering it that you're going to be making a board that's going to be able to connect with 4 LCD screens, and it's also going to be able to talk with 4 keyboards, and then it'll be able to output sound as well. So this is a nice project, and I think it's pretty easy to solder, but it does take a couple hours to solder it if you've got some soldering experience, more if you don't. But I think that even a first-time kit builder could solder this board as long as they were methodical and checked things out as they went step by step. So this board and this console, I think, would make a nice gift for someone interested in electronics or who wanted to get into electronics. This would be a perfect project to get them started. It's a little more complicated than powering up just an LED or something like that, but boy, you know, you're going to get a lot of satisfaction because you're going to be able to light up 4 screens and so forth. So that's a quick look at how you solder the Quby printed circuit board, and hope that helps you, and thanks for watching.